So here you have to good evening, students. So here you have to find out the problem is to find out vector x orthogonal to the row space. So you have what which is orthogonal to the row space? It is always a null space. So x is a null space and a vector y orthogonal to the column space. So vector y comes in the left null space and z orthogonal to the null space. That is a row space. So this is for matrix A is given. So reduce A to U, or we can even reduce it to R. So when you are reducing it to U and you are equating it to 0 null space, and you will be getting this x2 as a free variable, and we have x vector minus 2 1 0. The values of x2 takes, if I take the value of x2 equals to 1, you have the space as minus 2 1 0. So that is your null space vector, and you can say the x is orthogonal to the row space, that is null space. So x is a vector that is equal to the null space, and row space is 1 to 1. So z is a orthogonal to the z is a vector which is orthogonal to the null space. So that is nothing but a row space. So you have row space in z, and this is your x, and you have to find out y, which is orthogonal to the column space. So that is nothing but left null space. So A transpose you have to take and then find the null space of that. That is A transpose, null space of this itself is left null space. And you get the expression of, when you solve that, you get the expression that vector is minus 1 minus 1 1. So this is your vector y, which is orthogonal to the column space. So this was simple. Now coming to the next problem, we have what? This is a system of equations where we have no solution. So m is equals to 3, n is equals to 3 square matrix, and we don't have solution for this. You have to find out y1, y2, y3 to multiply the equation, so that they add up to 0 equals to 1. So you have to find, you have found a vector y in which subspace. So to get this, we have found y in which subspace they are asking. So you can try one of the column space or the null space or the left null space. Then you can satisfy if you are getting 0 equals to 1. So that subspace y belongs to. So here I have solved it for Ax equals to b. You can see b, I have taken b. So Ax equals to b. So this becomes a column space, and the solution of the column space we have. And here if I take if I want to find out column space multiplied with a b, what I am getting minus 17. So it is not equals to 0 equals to 1. So next I'll move on to the left null space. So randomly I have taken. So left null space, for that I will require A transpose and all of this to be equal to 0. So I have not included B here. So I have just reduced A to U, and here you are getting the expression. So look at the solution, what you get the solution, and just multiply x3 I have got minus 1 minus 1 1. If I'll take x3 value as minus 1, so it becomes what? 1 1 and minus 1. So just multiply 1 1 minus 1. This is your subspace, that is left the null space. Multiply with a b. So you can see 5 plus 5 minus 9 is equal to 1. So that tells you what? So here that the equation is satisfied with 0 equals to 1, and where it is satisfied when you are solving the expression in a left null space. So where you have found that? You have found it in a left null space. So moving on to the next problem. Find the pieces x, r and xn and draw the figure. So you have to just you have x, and you can split x into xr, row space and the null space. So A is given, values of x is given, this 2 has to be split into xn and xr. So how do you split? Xn is nothing but null space. So find the null space. When you find the null space, so you are equating this to, this is already in a U form, or you can even say it is in already in a R form, U form, both U and R form. So what will be null space? this is equals to ax equals to 0. So what will be getting? Here if I multiply 2 minus 0 will be equals to 0. So that is x1 is equals to, or you can say x1 is, if I just say x1, x2, so I'll be getting x1 is equals to x2. So automatically what will be your null space? X2 is your free space, so 1 and 1 will be getting. So this is your xn, and row space xr, that is your, what will be that row? This is your pilot element. This row itself I can write instead of transpose. So this is your row space. So you can just see the 1 plus 1 leads to 2, and 1 plus minus 1 gives you 0. So you have splitted x into xr plus xn. So here you can write x, then in a column, that is 1 as x star, is 1 minus 1, and xn as the transpose 1 1. What will be getting? You will be getting this equals to xn. Sorry, x. So already have found out the pieces xr and xn. Now just find out, draw the figure. So that figure already I have explained you. So this is the figure. So you have to write the row space, you have to write the null space, and the row space goes to it. It goes to column space, and the null space also goes to the column space. Sorry, the null space goes to this null 0, and the solution x goes to null space. So I can say x star plus xn total goes to on column space, or row space goes to column space, and only xn totally goes to the this point null space, that is null 0 vector. So you have, this is your left null space. I have found out all the vectors, just the column space and the left null space we have found out. And we have left null space 2 dimension is 2. You can check that, and column space with the dimension is single. So you have that. The dimension rank R was 1 because we had one single column R pi equals to 1. So R is equal to 1, you have row space, and you have xn, n was n minus, that is, you had 3, n was how much? N was 2.